It's 3:47 a.m. local time, and something impossible is happening over in Russia. 4 objects are racing toward Moscow at 380 kilometers per hour, completely invisible to the most sophisticated air defense network on Earth. They shouldn't have existed. The S-400 radar operator outside Ryazan was staring at his screen, watching what looked like a flock of birds. Except birds don't fly in perfect formation. And birds definitely don't fly straight toward Russia's largest oil refinery. At exactly 52 kilometers from target, 27 kilometers from the S-400 battery, the lead Beaver climbed sharply to 800 meters. The missile would need 27 seconds to reach them, but at emergency power, the drones could reach the 2-kilometer dead zone in 41 seconds. That gave the battery commander just 14 seconds to decide whether these were real threats or decoys. His thought process went a little something like this. Each missile cost $2 million, 10 seconds now. But the closure rate was real, 7 seconds. His training said wait for positive identification, 5 seconds. But if these were real, he fired. 2 48N6DM interceptors roared from their tubes, accelerating to Mach 6 in 3 seconds. But watch what the drones do. They immediately dove back to 200 meters, vanishing below the radar horizon. Here's the problem. These missiles use what's called semi-active radar homing. They don't have their own radar. They need the ground station to continuously paint the target with radar energy. Without that illumination, they're blind. The commander could only watch his screen in horror. His missiles were trying to predict where the targets went, but their onboard computers only had the last known position. They detonated 80 meters above where the drones had been, close enough that the 180-kilogram fragmentation warhead sent 24,000 steel fragments into empty air, not close enough to matter. Now, the refinery's last line of defense, 2 Panzer S-1 batteries, had exactly 17 seconds to acquire and engage. But the Panzer's 1RS-2 1E radar operates on the UHF and EHF bands and is optimized for larger targets. Against 0.1 square meter drones at 8 kilometers, the signal return was barely above background noise. 12 seconds now. The operator saw intermittent contacts flickering in and out. 8 seconds. They tried to slew their 2 A-38M cannons, but the hydraulic transverse takes 3.2 seconds to rotate 180 degrees. 4 seconds. By now, the lead Beaver had already identified its target. The warhead struck at 3:52 and 17 seconds. But this was just the first strike. 3 more Beavers hit 3 more targets in sequence. The cascade consumed 140,000 tons of petroleum. Within 90 seconds, the entire western section was an inferno, reaching 1,200 degrees Celsius. It would burn for 72 hours. Moscow's fuel supply had just been cut by 40%, and this was only the beginning. 470 kilometers away, 12 more drones were approaching their target. But this time, the Russians thought they were ready. They weren't. While the drones were still impacting the previous target, the Panzer S-1 batteries at Novokivishsk Refinery had been tracking the incoming threat for 11 minutes. 3 batteries arranged in triangular formation with overlapping fields of fire. Each system's 1RS-2 1E radar you see here could track 20 targets and engage 4 simultaneously at ranges up to 20 kilometers. The battery commanders had studied Ukrainian tactics. These drones would never reach their target, or so they thought. At 4:03 a.m., something strange happened. 4 of the 12 drones suddenly climbed to 1,500 meters, exposing themselves completely. Then the radar classification system screamed a priority alert that changed everything. The radar return signatures had transformed. The aspect ratio, speed, and radar frequency response now matched KH-101 cruise missiles. Here's what was really happening. The climbing drones had deployed corner reflectors, triangular pieces of aluminum that create what's called retro-reflection. When radar hits them, the signal bounces back at exactly 180 degrees with amplification. A 10-centimeter reflector can create the same radar return as a 10-square-meter object. The Panzer's computer saw cruise missiles because that's exactly what the reflectors were designed to mimic. The lead battery commander had 2 seconds to decide. His engagement protocol was clear. Cruise missiles are priority targets, always. His training took over. 8 57E6 missiles launched in 12 seconds, each accelerating to 1,300 meters per second. The missiles used command guidance for the first 18 kilometers, then switched to semi-active homing. But something was wrong. These cruise missiles were pulling 9G turns, impossible for a KH-101 which breaks apart at 3 Gs. They were multiplying. 4 became 8. 8 became 16. Watch what's really happening here. Each drone was dropping reflectors at 2-second intervals. The radar saw new targets appearing while the old ones descended slowly. $3 million in missiles were chasing aluminum foil that cost less than your morning coffee. But where were the other 8 drones? The answer came from his worst nightmare, behind him. While everyone watched the fireworks at 1,500 meters, 8 UJ-22s had approached from the opposite direction at just 50 meters altitude. The Panzer's fatal weakness? Its phased array radar is fixed. It can electronically steer the beam 45 degrees left or right, but to look behind requires physically rotating the entire 3,000-kilogram turret. That takes 4.7 seconds. The commander screamed the order, "Traverse, now!" Too late. The drones were inside 1.2 kilometers. The 57E6 missiles need 1.5 seconds to arm their proximity fuses after launch. At this range, they'd impact before arming. Only the twin 30mm cannons remained. The 2 A38M guns opened fire, each barrel firing 2,500 rounds per minute. The computer calculated the lead angle. At 200 kilometers per hour perpendicular crossing, that's 31 meters. But the UJ-22s were programmed for this exact scenario. Every 2 seconds, they executed what's called dynamic altitude variation, random changes between 40 and 80 meters using barometric altimeters. The Panzer's fire control computer uses predictive targeting, calculating where the target will be in 0.8 seconds when the rounds arrive. But with random altitude changes, prediction becomes probability. The hit probability dropped from 83 to 31%. One drone flew straight into the cannon stream and disintegrated 300 meters from impact, but 7 made it through. 3 of them found the target. And that's when the third group struck. All 3 Panzer batteries were reloading. The 57E6 missiles are stored in tubes below the turret. The automatic loader extracts spent tubes, refreshes fresh missiles, and rams them into launch position. This takes 90 seconds. 90 seconds of complete vulnerability. The Refinery took 3 more direct hits. The Ukrainian planners had calculated every second, knowing exactly when the Russians would be defenseless. But at the next target, Russia had just moved something the Ukrainians hadn't caught yet. At 4:18 a.m., 6 UJ-26 Beavers approaching Voronezh suddenly went blind. GPS signals gone. Communications dead. Navigation screens showed only static. A Krasuka 4 electronic warfare vehicle had just activated, and this wasn't ordinary jamming. The Krasuka 4 floods the electromagnetic spectrum from 0.1 to 18 gigahertz with 500 watts of directed power. To understand this, think about GPS signals. They transmit at 0.025 watts from the satellites 20,000 kilometers away. The Krasuka's jamming is literally 5 quadrillion times stronger than the GPS signal. It's like trying to hear a whisper while standing inside a jet engine. The drones automatically switch to inertial navigation using their gyroscopes. But these gyroscopes drift at 10 degrees per hour. After flying 380 kilometers for 68 minutes, accumulated error meant they could miss by 200 meters, and missing meant complete failure. The drone was now in full crisis mode. At 95 degrees Celsius, the processor began thermal throttling, reducing clock speed to prevent damage. But slower processing meant fewer pattern matches per second. the drone began emergency load shedding. Navigation lights off, saving 2 watts. Telemetry transmitter off, saving 5 watts. Radar warning receiver off, saving 3 watts. Every watt saved meant 0.5 degrees cooler. Every degree meant 100 megahertz faster processing. 30 seconds to impact, still no match. The algorithm was failing. 20 seconds, processor at 98 degrees. 10 seconds, thermal shutdown imminent. 8 seconds, the pattern locked. Not on the tanks themselves, those shadows were useless, but 3 tanks created a unique geometric relationship. The intersection of their shadows formed a triangle with specific angles. This hadn't changed. Tank 7 identified with 4 meters to spare, but the solution was trapped in one drone's computer. The Krasuka's jamming made communication impossible, unless the lead Beaver tried something desperate: frequency hopping spread spectrum, transmitting on 1,000 different frequencies per second in a pseudo-random pattern. The Krasuka can't jam all frequencies simultaneously with equal power. On channel 847 for 1 microsecond, there was a gap. The drone transmitted 128 bytes, just GPS coordinates and impact timing. The other 5 drones received the fragment through match filtering and adjusted course. Tank 7 took the first hit at 4:20 a.m. The warhead struck exactly where steel meets concrete, the weakest point due to the differential thermal expansion. The fuel lake ignited. The Krasuka 4 crew watched the wall of fire advancing at 30 meters per second. They abandoned their $20 million vehicle and ran. As the jamming cleared, 8 more drones appeared on radar screens. They were heading for Russia's most heavily defended military target. The Russians were about to learn that impossible was just Ukrainian for challenge accepted. Primorsko-Akhtarsk military airfield was a fortress. 4 Tor-M2 air defense vehicles arranged in perfect diamond formation with 5-kilometer spacing. Each section provided overlapping coverage with no gaps. 2 Su-35 fighters circling overhead at 8,000 meters. Every radar active, search, track, and fire control. The base commander had studied every Ukrainian attack, positioning his defenses using computer modeling. 8 drones against this meant a guaranteed shootdown. But the Ukrainians knew something the Russians didn't. Watch what the 8 UJ-22s are doing. They're not flying straight. This snake pattern, technically called a sinusoidal trajectory variation, wastes fuel. It adds 8% to flight distance, burning 4.3 extra liters in a one-way mission where every drop matters. Why? Because the Tor-M2 uses command guidance with predicted intercept points. Each weave forces recalculation. The fire control computer models target motion using Kalman filtering. But Kalman filters assume consistent behavior. Random weaving introduces what's called process noise. Small errors compound. By missile launch, the accumulated error could reach 50 meters. At 4:32 a.m. exactly, all 4 Tor-M2 systems fired simultaneously. 16 9M338 missiles accelerated to Mach 2.5 using solid rocket motors producing 4,000 kilograms of thrust. The missiles used 3-stage guidance, inertial for the first 2 seconds, command guidance until 2 kilometers from the target, then active radar for terminal homing. Their trajectories formed what's called a kinematic engagement box. No escape. 10 seconds until impact. The missiles were closing at 850 meters per second. 9 seconds. Terminal guidance activating. 8 seconds. The seekers acquired their targets. Then the impossible happened. The UJ-22s went vertical. Not a gentle climb, but a 6G pull-up that took them from 180 meters to 1,200 meters in 4 seconds. The missiles tried to follow, but couldn't. The 9M338 uses aerodynamic control with 4 canards. At the climb angle required, 76 degrees, the canards stall. Stall means the airflow separates from the control surface. No airflow, no control. The missile's thrust vector control could only compensate for 12 degrees. They sailed harmlessly below. Except one. Its proximity fuse detected infrared signature above. The drone's 180-degree exhaust at 400 degrees Celsius. The warhead detonated, launching 3,500 tungsten cubes in a directed pattern. The drone became confetti. But that spectacular interception served a purpose. Every eye, every radar, every weapon was looking up. Nobody saw what was approaching from the sea. 4 UJ-26 Beavers crossed the beach 15 seconds later, having flown 700 kilometers over the Sea of Azov at just 5 meters altitude. For 2 hours, they'd used radar altimeters to maintain height above the waves. The altimeters work by timing radio pulses, but seawater reflects differently than land. They had to constantly recalibrate. But the ocean route meant zero radar coverage. Ground-based radar can't see beyond the horizon, and the horizon at 5 meters is only 8 kilometers. The Shahed storage hangars were completely undefended. Inside Hangar 2, 30 Shahed 136 drones sat in maintenance cradles. Each Shahed carried a warhead with 40 kilograms of composition C4 explosive, RDX with plasticizers. Each had 50 liters of fuel. Do the math. 1,200 kilograms of explosive, plus 1,500 liters of fuel in a 40 square meter space. That's 30 grams of explosive per square meter, 10 times the NATO standard for ammunition storage. The first Beaver struck Hangar 2's roof. The hangar didn't explode. It launched. It reached 50 meters altitude before gravity reclaimed it. Hangar 3 went 1.3 seconds later. Hangar 4 followed. In 45 seconds, over 200 Shaheds worth $6 million were vaporized. The base commander ordered emergency scramble, but the runway was obscured by smoke from the burned drone flames. Visibility 150 meters. Minimum for Su-35 takeoff 200 meters. Primorsko-Akhtarsk, Russia's primary Shahed base, was eliminated. And the longest shot was still to come. But this time, the drones would face something they couldn't outmaneuver. At 4:44 a.m., 2 modified UJ-26 Beavers reached Penza, 630 kilometers inside Russian territory. This should have been impossible. The standard Beaver range is 350 kilometers. But these weren't standard. The modification was ingenious. Auxiliary fuel tanks in the warhead bay. They sacrificed 5 kilograms of explosive, reducing the warhead from 20 to 15 kilograms, but gained 12 liters of fuel. That extended range to 980 kilometers with 30 minutes reserve. Unknown to them, an Su-35 had been hunting for 20 minutes. The pilot was following close behind. His Urbis E radar was in narrow beam mode, 10-degree scan at 20 kilowatts power. This created what's called a power aperture product, concentrating energy for maximum detection range. Against the 0.1 square meter drones, he achieved solid track at 43 meters. The Beavers had nothing. No chaff, no flares, no jammers. That left only one option. The pilot selected 2 R-77 missiles and fired. These aren't ordinary missiles. They use active radar homing with their own Argus 9B2 seekers. Once launched, they're completely autonomous. The pilot fired at 18 kilometers and immediately executed a 180-degree turn. His job was done. Now it was the missile's turn. The R-77s accelerated to Mach 4 using solid rocket motors. They would cover 18 kilometers in 13.2 seconds. At 12 kilometers, the seekers went active. Each seeker could track targets pulling up to 12 Gs. The drones could manage 6 Gs maximum. But the drones could do something the missile could not. Barrel rolls while varying altitude between 150 meters. The idea was creating angular velocity that exceeded the missile's control response. The R-77's control system updates at 100 times per second. The drones were changing direction at 150 degrees per second. This created what's called gimbal lock. The seeker physically couldn't rotate fast enough to maintain lock. The first R-77's proximity fuse triggered at 80 meters. Hundreds of 8mm tungsten balls traveling at 21 meters per second perforated the Beaver's fuselage. Control surfaces locked at random angles. Half the vertical stabilizer was gone. But the engine kept running. The second missile didn't miss. Direct impact converted one Beaver into aluminum confetti. But its damaged wingman wobbled onward. The flight computer calculated impact in 40 seconds. Current trajectory would miss Building 3 by 40 meters unless something changed now. Final 3 seconds. Maximum thrust pulse. 30 meters off target. 20 meters. 10 meters. Impact at 04:46 hours. The Beaver crashed through the roof at 73 meters per second. In normal circumstances, 15 kilograms of explosive wouldn't devastate an industrial building. But semiconductor fabrication is different. The clean room's air filters, designed for 0.3 micron particles, were instantly overwhelmed by millions of concrete and metal fragments. The electron beam lithography system, 47 million, 18 months to install and calibrate, was destroyed. The ion implantation equipment vaporized. 6 months of military processor inventory became silicon dust. Russian military chip production was paralyzed for a minimum of 6 months. Within 6 hours, Russia would begin the largest air defense redeployment of the war. Each system protecting refineries meant gaps in battlefield coverage. Each gap meant Ukrainian HIMARS would operate freely. Ukraine had spent $412,000 in drones to inflict tens of millions of dollars in damage. But the real victory wasn't monetary, it was psychological. If Ukraine drones could reach Penza, 630 kilometers from the border, they could reach anywhere. Bye for now.